Let me know when you start.
Yeah. Now we're recording. Okay, so go ahead.
We're recording.
And try
Okay.
to, try to share your screen now.
You have to enable it first.
Yeah, it's enabled, right?
No, not yet. It
Oh.
says host disabled. Yeah.
Okay, go for it.
Ready? Okay, got you. Perfect. Screen 2. What's up, bro? What's up?
What's going on?
So we're gonna go over first question 1. Let me show the question for the recording. Hold on, let me find it. Part one. Is it this one? Should be this one. Okay, so this is our question. Is the 4 difference formula can be expressed as, and then it gives you this formula. They want us to use extrapolation to derive an big O of H cubed formula for f prime of XO, right? So if you look at this formula, it's actually directly from the notes he gave us. So let me go to our notes. So this exact same question was given to us on our notes. And if you look at the definition, it's actually the Richardson extrapolation. So this is the formula 1 over H, and then you have the f of XO, X naught plus H minus f of XO. And then it continues all the way to big O of H cubed, right? So we want to use Richardson extrapolation to find a big O of H cubed formula for f prime of X naught, right? Same exact question. And down here, he gave us the answer here. M equals f prime of XO, right? So that's why we replace f prime of XO with M, right? So we do M equals this, and then we start subbing, right? So you know how it's K1, H, K2, H squared, K3, H cubed? It's the same method. So N, which is the first one, it's usually N of H. So N of H is going to equal this first block, right? So N of H equals 1 over H f of X naught plus H minus f of X naught. Then K1 equals negative 1 over 2 f prime of X naught, right? So you can see that right here. I'm not 100% sure why he uses 1 over H, but I'm pretty sure it's because we do multiply it by H. So this should be K1H. So when you multiply, it'll give you negative 1 over 2, and then you just multiply the H, of course.
Yeah.
Now this one is K2. It equals negative 1 over 2 f triple prime of X naught. Again, this should be K2 times H squared. So that's why you do it H squared over 2, right? So basically, we're just breaking it down, right? So what does N equal? N equals this first block, right? What does K1 equal? K1 equals this block times H. What does K2 equal? K2 equals this block, or this, little sequence here, times H squared. And then we finally have big O of H cubed, right? So that follows that M equals N of H plus K1H plus K2H squared, right? Makes sense, right? How the formula, derives itself. So now from the general procedures described above, where we have it like that, we know that M equals N to the second, what is this? N2 of H plus big O of H cubed, right? Where N2 of H is 1 over 3, 4 N1 H over 2 minus N1 of H. We actually get that by doing the procedures by, we have to do a little sequence where we cancel. It's what we did in class, where we did the M times N, and then we would cancel the H1, and then we would stay with the K2, and then that would finally give us that N2 equals the 1 over 3, and then N1 is going to be 2N H over 2 minus NH. And then this just shows you how we, derive it using a trapezoidal method. And the final answer should just be this, N2H, and then we put and N1 equals this. So if you put these 3 things, M equals this, N equals this, and then N1 equals this, you should get the full points. I think you should get the full points, because that's basically what it's asking. Now we're gonna go on to the next question. Finesse, did you get that, bro? All good?
Yeah, pretty good.
Yeah, no, I'm good.
All right, perfect. Next, we're gonna be working on this one. just a heads up, I didn't do too well on this one, but I do have it from when he did it with us in class. This one I messed up because I asked him if it was x9. He said no, it's f of 0. So I messed up. So Gerardo, you might want to send that one.
Yeah, I can send that one.
Okay, but the next two I could of course do. So let's work on this one. This one's pretty easy if I could find it. Okay, this was pretty easy. Let me actually save it. I could open it up. So I always start with a midpoint just because I think it's the easiest. So we have the formula. This is the formula we're given. Integral of 0 to 1 of natural log to the or e to the x plus square root of x plus 1 dx, right? So of course we already know that for midpoint, our h is going to be b minus a over 2, right? So we go here, b 1 minus 0 divided by 2 gives us 0.5. So we have our h. Next, we want to find our x naught. X naught is just b plus a over 2, which gives us 0.5 as well, right? Here I drew the little, the h's. So it's from 0 to 0.5. X naught is 0.5, and then x naught to 1. So you already have the midpoint. This is the midpoint. So you want to plug in the formula 2h f of x naught, right? That equals f of x. So it's going to be 2 times 0.5. And then for x naught, which is going to be x and x here, you plug in 0.5. This should give you an approximation of 2.87 when you plug in everything. Then our error is h cubed over 3 times the second derivative. As you can see right here, I have the second derivative right here. So I just plugged it in. And you want to make the derivative as large as possible, right, Gerardo?
Yeah.
So I put it 1 plus 1 here, so it could be as large as possible. So then when you plug it in here, 1, because it's the interval 0 to 1, so I put in ones. You're going to get 0.1096 as the error, right? And then here I showed that if you subtract.
Wait, go back.
this- Where?
Wait, so for that, okay, so for the error, actually you would put 0 plus 1, right? Because, okay, first of all, that's a negative exponent, right? So it's like you want to make the number in it like smaller. You know what I mean?
So it should be 2.
No,
It's 1.
well,
It's 1. Okay, so this is 1 over 4 times 1 plus 1 to the 3 set to the 3 second.
yeah, exactly. So I'm saying that you need to put, okay, so you can put in.
Oh, so it should
e to
be
the,
1.
okay,
So
you can do e to the first. That's okay, but I'm saying
it'll be
that
0.
obviously it doesn't really matter. You don't have to like what I'm saying is that for this one, just put in like 1/4. I'm sorry.
Times 1.
Like instead of 1 plus 1, it should be 0 plus 1. Like you want to make it
so it
as
can make
big
it
as
larger.
possible, but that's how you have to do it because it's a negative exponent.
Correct. So this would be an accurate error if I would have put 0 correct. Now to check my work, what I did during the test was this. I actually calculated the integral using my calculator. And then what I did was I subtracted that. But I subtracted my approximation by the error, and I got something close to this. Because if you look at the actual formula, if you subtract this, but approximation, it should in fact give you something close to this. That's just, to check your work, make sure you're accurate.
Yeah.
Next, we use trapezoidal. That's gonna be h over 2 times f of x naught plus f of x1, right? X naught is just a, x1 is just b, h equals b minus a. So you want to remember, midpoint Simpsons is h equals b minus a over 2. Trapezoidal, just b minus a, which just gives you 1. 1 minus 0 is 1. So since my h is 1 because it's 1 minus 0, you just do 1 over 2. And now x naught is x naught is a, which is 0. So you plug in here zeros, then you add it to x1 is b, which is 1. You add it to ones here, fill in the formula, gives you approximation of 3.06. Now this is the error formula, so we could get our error. Again, Gerardo said I should do 0.
Yeah.
0 plus 1. So this again should be a 1, but the error I think is accurate enough for example. So this is a second derivative again. And then again, how I check my work to make sure it's, you know, similar. Take this, subtract it by this, and it should give me something close to the actual integral. It's just a tip, you know. I don't know if that's the actual definition, but that's how I read the definition. You feel me? Simpsons, this one's a little, so let me tell you a way to remember. So this one's 2 times h, 2 times h over 2, 2 times h, then h over 2, then h over 3. You want to remember like this. This is just h over 2, h over 3. You go down, midpoint, trapezoidal, Simpson. H over 2, h over 3. But of course, you got to remember the 2 and then fx. Just the way I remember it.
Yeah.
I always do it in that order. All right. So this is h over 3 times f of x naught plus 4 f of x1 plus f of x2. So we know x naught equals a equals 0, x1 equals b plus a over 2, just like in the midpoint. But it should in the midpoint it's x naught, but here it's x1 because it's the point in the middle. So that gives you just 0.5. So it's 1 plus 0 over 2, 0.5. Then x2 equals b, which equals 1. So you have 0, 0.5, 1. And then h also equals 1 minus 0 over 2. Gives us 0.5 again. So what we do here is we plug in h, 0.5 over 3, plug in 0 for our formula, then plus 4 of x1, then we plug in x1, then plus x2, we plug in x2 here. This is our approximation. And Simpson's rule for the error, from what I remember, he said it's the one that's the smallest error. So you take the error, which is negative h to the 5th over 90 to the 4th derivative. So 4th derivative, I have it here. And when you go down here, again, this should be a 1.
Yeah.
Well, you get a negative 0.50 to the 5th over 90. Then I plug in 1 here to make this the largest, and then this should be again a 1. But as you can see here, this one has the smallest error. Simpson should give you the smallest error usually. So don't be surprised if your error is like super tiny, you know. All right, guys.
Yeah, that's pretty good. Yeah, the only really problem here is that like you like for for error, like you yeah that's the thing. Like it's just like it doesn't really matter. Like you don't have to make it the same number. Like whenever like with the x's that are there. You know, at the end of the day, you just have to make it bigger, right? So you can just put in different numbers, right?
Yeah, of course. Okay, let me send.
So now we're gonna go over a question of 3. I actually got this one right.
I have it from his notes, but you rather send yours and explain it, or what do you want to do?
Yeah, I'll explain it.
Okay, explain it. Go ahead.
I got it.
Let me stop sharing them.
All right, bro. All right, so let me share.
Where's the rest of everyone, bro? No one shows up, and then they bitch about their grade.
Okay, so let me just let me pull up Discord. Right, because I uploaded on Discord, so it should be there. Okay, let's see here. All right, so okay, you guys see my screen, right?
Of course.
Okay. All right, so here's exercise 3, right? So let me just look at, okay, first of all, let me just see the question first. You already uploaded that right here.
I use Eric's.
Eric's? Wait, it's on Discord, right?
No, it's on WhatsApp.
WhatsApp. Okay, so where is it? Like,
you go to click where it says like no next to that, like on the numbers, click on the phone numbers. Yeah, click there. Click on the phone numbers. Now scroll down. There you go. And then click media links, etc., and it's gonna be
this.
It's not that one, but it's one of, you know.
Yeah.
You just scroll down. It's by the shirt. Keep going. Keep going. That's part 2. Keep going. Okay, there you go. Oh, you passed it.
Okay.
No,
I just want to see the question first. Yeah.
No, it's like one of the first.
Oh, okay.
Yeah, it was higher, bro. It was higher. You passed
higher?
it. Yeah, you passed it.
This one?
Higher? No. It's towards the end, bro. It's towards the end.
Towards the end? Okay.
Towards the top.
Yeah. Bro, we're just trying to find the. Okay, so it's
there. You passed it. Yeah. You see the one that's like yellow? No, you see the one that's like yellow?
Yeah.
Under it. There you go.
All right, we just want to see the question, right? So it's basically about, okay, find the degree of precision
It's about the
Okay.
quadratures. Those were kind of difficult.
Yeah. Okay, so basically it gives you this quadrature thing, and it's from -1 to 1, and you have this, right? And it's finding degree of precision.
Yeah.
Oh my fucking goodness. So basically, like, yeah, it's basically K, right? That's all it is. Okay.
Yeah.
So I have that equation like written out here. Okay. And so you basically start from K equals 0 and you move up until, they basically don't match each other, right? That's the idea. So you're going to see right now. So K is just the exponent. So X to the K. So it's just 1, right?
Yeah.
So that means a 1 is your function. That's all it means. And so this means that now f of X is 1 in this case. So you do the integral of 1 from -1 to 1. Obviously, like, the
Just
integral
one,
of 1 is X, and then basically it equals 2, right?
Yeah.
And then you plug in negative square root of 3 over 3, positive square root of 3 over 3. Basically, like, you plug those into the function here, right? And obviously it's a constant function, so it's just 1, right? So it's 1 plus 1, 2. So notice that both these guys equal each other. So what that means, you have to keep going, right? Now you have to go to K equals 1, and then so on, right? You only stop when both this and this, when they don't equal each other. And that's basically it. And so when they don't equal each other, basically you say, okay, this is your degree of precision, right? K equals
Wait,
whatever.
Gerardo, how do you know that square root of 3 over 3 is equal to 1 plus 1?
No, because remember, this is like, okay, so
X.
negative,
It's
okay,
gonna
so
be 1.
root 3 over 3, you're just plugging that into the function, right? And the function you get is based on X to the whatever exponent you're at right now. So right now we're at 0, so X to the 0 is just 1. So 1 is the function, right? And so when you plug that into this, well, obviously it's a constant function. Regardless of what you plug in there, it's always going to be 1 that you're going to
So
get
it's
out.
just 1 plus 1.
Yeah.
Regardless. Okay.
Imagine
Because-
imagine the root 3 as X as to the 0th power. They're gonna be to the 0th power.
Okay. Okay, perfect. So then it's just
So yeah, if you look at what he said, like with K is equal to 0, X of K is equal to X to the 0 is equal to 1. So negative root 3 over 3 to the 0 plus F of root 3 over 3 to the 0, which is 1 plus 1.
okay. Perfect.
And that's
Yeah.
what's usually going to happen for the first case anyway.
Yeah.
Okay,
Makes-
so then you go to K equals 1, right? So now X to the first power, now it's just X, right? That's your function. So you do the integral of X from -1 to 1, and you do that and you end up with 0, okay? Then you do the same thing. So you plug in, root 3 over 3, both the negative and positive one, you plug them into the function X, right? So,
Yeah.
and as you can see, both of them are 0, right? And then you keep going. And then you get to K equals 2. So now the function's X squared. So you do the integral again, right? So this one ends up being 2/3. And then you do the same thing. You plug in, plug in both these guys into X squared and you add them, right?
Yeah.
Basically same thing. They're also 2/3. And so you keep going. I think, yeah, the degree of precision is K equals 3, right? So one more time again, right? So X cubed. So you do the integral again, equals 0. Same thing here. These also equal 0 as well. Okay, so when you get to K equals 4, notice that, like, basically when you do the integral, it equals 2/5. But then when you do, I guess, I don't know what that's called, basically like your approximation, I guess.
Yeah.
You plug this in, and then what happens is that it just equals 0, right? So they don't equal each other. So that means that K equals 4, it doesn't work, right? The highest we got was K equals 3. So that is your degree of precision. That's basically it. Is that good?
Yeah, now that you explain it, makes sense. I see what I did wrong. So basically, you just whatever K is gonna be now the power of each of the f of x's. Just as the cases go for the f of x that we have. That's why it's 1, x of 2, x of 3. Makes sense now.
Yeah. All right. And do you have question 4 as well?
Which is question 4?
It's the one where it's the one
That
where
one I
it's
got it
like-
wrong. That one I got it wrong.
Oh, okay.
because-
Yeah, okay.
because-
I can do that one too. I got that one right.
You got it right? Yeah.
Yeah.
Please show me. Because I asked
Yeah.
him, is it f of x 9? He said no, it's just f of 0.
All right, let me upload this guy.
Hello, Charita. Hello.
Commented up.
All right, so it's on Discord. So let me just pull it up.
Dude, I'm emailing the professor if I could turn in the project after the exam. And should I include telling him that I need the project to help my grade as my fellowship depends greatly on my GPA as my FIU fellowship? Should I include that or no? Just so he could be like, oh, you know.
Yeah, I mean,
kind of heavy.
can-
I'm working on the project right now. It's really, you don't have to do the code. You just have to find some way to get the data and graph it. But me, I'm doing the code.
No, I know it's easy, but it's like I don't want to start something else until I finish this. You feel me? But should I mention to him like, oh, my GPA depends on a fellowship, just so he could be like, oh, you know, a little bit more lighter on me?
yeah, I
Or is
mean, I
that
don't think
not
it's
a
a bad
thing?
idea.
I'm like, good afternoon, professor. Would it be okay if I turn in project 2 tomorrow after exam? I've been studying a lot and haven't had much time for it and wanted to continue studying for tomorrow's exam. I need this project to help my grade as my FIU fellowship depends greatly on my GPA. Thank you so much. Best regards.
Yeah, that sounds good.
Yeah, and I'm really worried I'm gonna get a C in this class, so I'm like, you know, shitting bricks. And
Yeah.
I mean, Gerardo,
No,
you're my
and by the
witness.
way, not only that, but all of that was recorded. Like we all know about it. So
What do you need?
yeah, I'm
Oh.
recording this.
Come on, yeah, but I'm not doing nothing illegal.
Yeah,
All
of
right,
course. Yeah, I mean, it's not illegal to say like, hey, help out, help a brother out.
Hey man, if I did good on my thing, you gotta give me an A, bro. All right, so explain this one and I'll take notes because I need to take notes.
All right. Yeah. So wait, do you need time to get your notes or whatever? Or?
No, I could just
Oh,
copy
this is
it
with
down.
C. I ran out of time. Okay.
Okay. Yeah. So I just copied down the equation here. So it's the integral, this thing. So C0, C1, they're just constants, right? That's all it is.
Yeah, of course.
So, okay, so basically it's the degree of precision thing. So it's basically the same thing that you just did in question 3.
Yeah.
This time it's just you're trying to solve these variables, right? It's just like the cubic squaring thing.
Yeah.
So k equals 0. Okay, so your function is 1 basically. So you integrate 1, that's just equals 1.
Yeah.
You do this, okay. Basically, when it comes to the f of 0, the f of x1, it basically all you're doing is that you're just taking like you're basically taking like those values, right, 0 and x1, and you're just plugging them into your function, right? And so the function in this case is 1, right? Because x to the 0 power is 1, right?
Yeah.
And so you plug in 1 into this stuff, right? So it's c0 times 1 plus c1 times 1. Obviously, it's just c0 plus c1.
Hold
right?
on. So
Yeah.
so it's f of 0 to the 1 power or
No, okay, don't think of it as like x to the 0, right? Because remember, you can simplify that, right? X to the 0 equals 1, because anything raised to the 0 power is just 1, right?
yeah, of
And
course,
so,
but
right.
what I
So
don't get is because I'm used to actually plugging in 1 for f of x naught, right? But now it's f of 0, so that's where I get thrown off. You get what I mean?
yeah, no, that's just saying 0 is what you're plugging into the function, right? But the thing is that it's a constant function, and so that means that so whatever you can plug in 1000, you can plug in like pi or whatever, like it will always give you back 1. You understand? That's what that means. So if you plug in, so f of whatever, if the function is just 1, f of whatever is always going to give you 1. You know what I mean? And so you can think of this as just c0 times 1 plus c1 times 1, right? It's always going to be 1 because that's the function 1. You know what I mean?
It's just when I see 0, I multiply, but we don't know what the answer is. So isn't it just going to stay as f of 0?
No, you know what the answer is, because the function is x of 0. I mean, x to the 0 power, which is 1. And so you already know what the function values are. You get what I mean? Because you get the function from doing the degree of precision thing, right? So your function is x to the k, and k is the number that we're on right now. You get what I mean? And so you already have your function.
All right.
Right. So in this case, so you have c0 plus c1, and this equals 1 because this has to equal this, right? Like both these guys.
Yeah.
And so, this 1 comes from the fact that this was 1. All right. So yeah. So that's your first equation. And then you go to, it's the next precision, right? K equals 1. So now your function is x, right? Or x to the first.
Yeah.
And so you integrate this. This is just 1/2. And then you do this, right? So you're plugging in, so in this case, you're plugging in 0 into the function x, which is just 0, right? So c0 times 0, that's just 0, right? So this is gone. You plug in x1 into the function x, which is just going to give you x1, right?
Uh-huh.
And so you do the math here and you end up with C1 times x1 equals 1/2. You know how we got that, right?
So does the f of 0, does it just dissolve with the, does it just
No, it doesn't. It doesn't just dissolve. You have to understand that. So the function is x right now, right?
yeah.
So the function x means it's the identity function, right? And so when you plug in, so like for example, f of 2 in this case would be 2, f of 3 would be 3, f of 4 would be 4, etc., right? And so f of 0 is going to be 0, right? So that's where the 0 is coming from. But obviously C0 times 0, that's just going to be 0. It doesn't matter what C0 is. It's just going to be 0 because you're multiplying it by 0.
So the actual function is just x. So when you plug in x, it just, oh, okay. So for example, since 1 is a constant, f of 0 just gives you 1.
Yeah.
And then since f of x, when you plug in 0, just gives you 0. So that's why it's 0. Okay. I understand now. It's because remember how we did it in class was different. So I never actually like got used to it. But yeah, continue, bro. Thank you.
Yeah, okay. So now you have these two equations. All right, now you go to the next one. So k equals 2. So now the new function that we're dealing with now is x squared. So again, you do the integral, you end up with 1/3, basically. And then you do this again. So you plug in 0 into the function x squared, you plug in 0 into the function, you plug in x1 into the function x squared, right? Which is just x1 squared, basically. And so this is just going to be C1 x1 squared equals 1/3, right?
Yeah.
So you have all the equations you need, right? And so at this point now you can just solve it, right? And so how I solved it was that I solved for x1, right? Which is 1/2 C1. This is just algebra, right? So I'll just kind of skim through this, right? So you do that, you plug that into the into this equation, right? Because it's like squared. So obviously you wouldn't do it the other way, right? Because then you'd be dealing with like a square root and that gets complicated. So that's how you do it. And then you end up, I just kind of complicated this, but basically C1 equals 3/4. And then once you have that, then you know that C0, right, is just 1/4. And then just like that, x1 is 2/3. Okay. So yeah, does that make sense?
Yeah. Now it makes sense now that I know that I just plug in 0 into whatever the integral becomes. Now it makes sense, bro. Thank you.
Yeah, no problem, my guy.
All right.
I'm stressed, bro. Stressed with all this stuff, dude.
All right, so now we're gonna do part 2 of exam 3. I got a perfect score on this, so I'll just upload it.
Oh, the heck was that?
Huh? I was
What was
celebrating.
Said what?
I was celebrating.
Dude, I thought there was someone else joining. I was like, what the heck is that?
Hey,
Yeah,
why
probably
does it say I'm playing Hearthstone?
That's what I thought.
Says you're playing Hearthstone, bro.
Yo, it doesn't say I'm playing Hearthstone.
Ah, you're playing video games while study, bro. What's going on?
Oh, no, because my Mac has Hearthstone. My laptop has Hearthstone open. And I keep my Discord open 24/7 on my laptop. I'm coding, actually.
Oh, yeah? Shit. All right, Jerry Rardo. Bro, how do you think we're gonna do on this exam, bro?
Horrible.
You think he's gonna go for real? Oh man.
I know personally.
I mean, I don't know if he's gonna curve it though, but I mean, he hasn't curved so far, so I don't know about that.
He hasn't?
No,
he
I
hasn't
don't
put
think
in any
he's
grades. He hasn't weighted any grades yet. I think he's gonna add normal weight values to the grade and then curve after.
How do you know? He says something about it? Or?
No, but that just seems to be what makes the most sense, because if the professor isn't constantly putting in grades, if a professor doesn't have your grades weighted already, it would make sense that they would wait till the end to see what the class average is and then curves it. Because he always talks about, a lot of people pass with a B, So it seems like, he's been very generous on like points. Like I did like the most recent homework. I did half of the homework. I turned in half of the homework and I turned it in late and I got 16 out of 15 points.
16 out of 15?
I don't know if he's going to change that.
I doubt it.
But he can't change that. He can't.
I doubt he's going to change it. He's not going to go back in and change it.
Yeah. So I feel as if, as long as you because he's always says, I'm concerned about the process, not the answer. I think as long as you've been consistently showing effort in the course and your grades aren't god awful, you're going to pass with a C or a B. If you literally don't try, then that's when you're going to fail.
Yeah, like look, my exam grades have been 21 out of 40 on the first one, but everyone did bad on that one. 35 out of 35, 25 out of 35, 30 out of 40, 31 out of 45, 20 out of 30. You feel me? It's not like it's been straight F's. It's been, C's and some C's
Yeah.
and A and some B's, My
Mhm.
homework has been 16 out of 15,
Mhm.
16 out of 15, 14 out of 15, 15 out of 20. You know what I mean? Like I've been turning in homework. And I'm turning in both projects, and I did the spot. I even emailed him. I was like, hey, I've been harassing everyone. Do the spots. And he was like, oh, thank you so much for getting participation. You feel me? Like I've been showing him, hey man, like, and now I've even emailed him, hey bro, like, can I turn it in layout? So I think since he's like his score is a 5 on Rate My Professor, must be for a reason. You feel me?
Wait, it was 5?
He has a 5, yeah. Even if it was just one kid, So I don't think he's gonna, if we, he sees our faces, he knows our names by now. He should know who does what. You feel me? So I feel like,
bagels.
yeah, no, but I didn't do that for a curve.
No,
I
no,
just did that out of kindness. But
I get that.
he probably remembers it though.
All right, bro. So yeah, all right. So now let's go over the part 2.
Let's
I
do
think
it, bro.
after this, I think we can just call it a day, right? I mean,
Of course. Oh wait, we have to go over 8.2 also though.
Do you have the,
yeah, you're right. You're right.
do you have the
8.1
recording of the
8.2.
last session, like the other 2 exams?
Yeah, he put on his YouTube.
Okay, thank you. Send me the link to that YouTube because I need, those are the exams I'm struggling with. Like the most
Yeah.
recent stuff is very fresh in my mind, but the other stuff I need to brush up on.
Yeah,
Oh,
yeah.
definitely,
I
bro.
put the link on the. How about this? Like on the WhatsApp, I'll send you the link again to the YouTube channel. So I mean to the video.
Thank you so much.
I put the
Yeah,
link
no
in the
problem, bro. Yo,
description.
anything for my homies. You know what I mean?
Appreciate it.
Thanks, homie.
An error.
All right, guys. So okay, so okay. So all right, so question 1 is find the approximation. So you're using the composite rules, right? That's all it is.
Correct.
So all right,
You want me
let's
to go
see.
over that one, bro?
Um,
You could take a break.
yeah, go over this one. Why not?
Okay, let me find my
Yo, let it rip, bro.
letter in. 1, 2, 3. Hold up. Let me find my exam 3 part 2. Found it. Okay. Let me just upload. So this one I got 28. I got a 28 because on the last one I did a little oopsies. Not
Yeah,
not
but
because
you,
of
but you
anything
did get
else.
full credit on question 1, right?
Oh no, definitely, bro. I went off on question 1. I did everything correct.
All right.
As well
awesome.
as question 2. Question 2 as well. I did really good.
Yeah.
So let me just, I could actually do 1 and 2 and then I'll let you do 3. I
All
just don't
right,
want
bro.
you to get tired.
Let's do this shit.
Finesse, but do you think I explained well or do I need to work on it? What do you think, bro?
No, you're good, man.
I'm
I'm
good?
low key not. I'm low key half in, half out. But that's because I'm coding the project and that
No,
variation.
I don't blame you. I don't blame you.
But no, because when if you say something that doesn't sound right, I'll chime in. Like when you weren't getting the x, like the k is equal to 0, x to the 0.
Yeah, bro. I
Plus
was
one.
like, what
Yeah.
the hell?
Yeah, so I'm paying attention. But you guys are good. If something's
got it.
off, I'm gonna chime in. But you guys are good.
No, I got you.
Thank you also, by the way, you guys.
Of course, bro.
Yeah, no problem.
I also did this one correctly, so I'll send it. I'll send these 3 and then I'll let you do the last one. I want to have some
Right.
practice too.
Um,
Let me send them in.
Yeah.
This one, this one, this one.
Bro, I'm gonna get 1 million subscribers, bro, out of these 2 videos right here.
You could just put tags and then people actually look it up on YouTube, like future of his students, and they can actually learn, bro. It's not a bad idea to put tags. That's how
Tags?
most.
You mean like hashtags, right?
Sort of like in YouTube, you could put tags. You could put like tag. You could put literally numerical analysis, and people be like, "Oh shit, they have one actually for my class," and people subscribe, so they won't lose your page. Okay, guys,
Yeah.
so this is what we're gonna go over. We're gonna go over approximation using the composite rules, and we're gonna be using 4 subintervals. I think he said that if he doesn't mention how many subintervals, you just go with 4 by default. So that's actually something important to remember, so you won't get lost during the exam. We got with this. So I actually did all 3 on the same page. but this is different. Hold up. Two. Let me save this one as well, and then let me save this one. This is the one we're going over right now. And is this one? Am I missing one? CTR midpoint. Yes, I am missing one. Give me 1 second. Let me send Simpson. Simpson was the longest one. So wait, I thought I did send it though. Give me 1 second. Yes, I did do it. Okay, perfect. Just have it up there. All right. Now we could start. Okay. So I started off with the trapezoid. So since we're doing composite and we're doing 4 nodes. Actually, no, this isn't the one this isn't the same one, is it? Is this one, right, Gerardo? Or no?
Whoa, I think we went over that one already.
I think I sent in the wrong thing then, did I? Hold up.
Whatever, it's fine. I mean, how about this? How about I show mine, but you try to explain it for my work because I feel like it's more organized.
No, but it's that I did do it.
No, but I mean, it's there, right?
Unless I'm losing my mind.
No, that's the thing because it's not labeled, dude. It's like we have no idea like from which exam it comes from.
No, but I have it here. Hold up.
Are you sure that's the one, bro? Because like, how do we know?
I have the exams in my hand. Okay, so this is part C. So that I have, right?
Mhm.
Let me go back to WhatsApp. This is a different one. Different one. It's a different one. I see what happened. I forgot to send in this one. Hold up. Now I fix it. Problem solved. It's just since I have a headache, it's kind of hard for me to, but I want to explain it because it helps me practice as well.
Yeah, of course.
Okay, let's download it. See, now I have it, right? Perfect. All right, so I start off in the midpoint rule. That's what usually I do. So right now we're integrating from the integral of 1 to 2 of x ln x. So he actually gave us a pretty easy integral for this one. So the first thing we want to do is we want to break it up into 4 subintervals. As you can see right here, he wanted us to do 4. So h equals b minus a over n, right? So we can do 2 minus 1 over 4. That gives us 1 over 4. So what you do is you actually break your our little number lines. You know, it's always good to make a number line. We break it into 4 intervals, right? 5 over 4, 6 over 4, 7 over 4, 2, right? So then 1 to 6 over 4, the midpoint of that is 5 over 4, right?
Yeah.
Then from 6 over 4 to 2, our midpoint is 7 over 4, right? So then we only do this. The integral of 1 to 2 using the composite method of f of x from 1 to 6 over 4, we put f of 5 over 4. Then from 6 over 4 to 2, we put f of 7 over 4. And then our h is the same thing, 2h f of x 0, but we're just breaking it down into 2 intervals. That's why you see me do 2, 1 over 4 times 5 over 4 ln 5 over 4, which is, you know, just this, plugging in 5 over 4, plus 2, 1 over 4, 7 over 4 ln 7 over 4. So if you actually see here, I get 0.13946 and then 0.48937. So then it just gives me this approximation. Now, for the actual error, I get h squared over 6. This is the error for composite midpoint times b minus a. It's important you remember the b minus a. It's for the composites, b minus a.
Yeah.
So you do 2 minus 1. In this case, it's just 1. Then I get the derivative, the second derivative, which is just 1 over x. And then when I plug in the 1 over 4h and then over 6 times 1. And then when you plug in 1, just to make this as large as possible, you get this error, 0.01.
Yeah. Yo, by the way, I actually have my I have like the same like exam in front of me. So like, cause honestly, like I
Did I
just
do
checked
something
right now
wrong?
and you have the same answer as I do, right? So you're
So I
good
did it
so
right?
far.
Okay. How about here? 2.56 and then 0.00521.
Wait, that's CTR. Let me see. So
Because I feel like I did my Simpson wrong. I feel like I did Simpson wrong.
okay, for trapezoidal, I got no, I didn't get what you got, bro. I got 0.6399.
That makes sense.
Yeah.
I
And then
what do you
show
think
me
I did
your
wrong
Simpson.
here? Simpson, I definitely did it wrong. I got 5, but he still marked it right just because my process was right. It was
Yeah,
just my
okay. For
math was garbage.
Simpson, I actually got 0.6363. Like, that's the thing. It
Makes
has to be
sense.
like 0.6 something, right?
Yeah,
for the
yeah,
answer.
yeah, definitely. Because when you actually take the integral of this, it's a really small number. So I'm gonna explain the process and then we'll just see what I probably did wrong was just the math, bro. Because in my calculator sometimes doesn't do the right thing. So H is just the exact same thing. B minus A over N because it's composite. So it's not just H equals B minus A for trapezoid. So what we do is we break this one into 4 intervals again. We go from 1 to 5 over 4, 5 over 4 to 6 over 4, 6 over 4 to 7 over 4, 7 over 4 over 2. So what I like to do is just multiply this by 2. That might have been what gave me the wrong approximation. So I did 1 over 4, which is H over 2, which is just H over 2. And then I start plugging in. This is my f of x0, right? Because it's like this. It's 1, then f of 4. Sorry, 5 over 4, then 5 over 4. So 5 over 4, then 6 over 4 to 6 over 4, right? So you gotta the middle ones here, these get multiplied twice. So that's why I did it by 2. But I guess it might be better to just do 1 by 1. So I did f of 1 once, right? Because you only see it once. Then 2 times f of 5 over 4, f of 6 over 4, f of 7 over 4, because you see these twice, right? You see it twice here. And then plus f of 2 once, because you only see it once here, right? So if you actually draw this out, you could actually see which ones you're going to multiply twice. Because each of these gets multiplied at least once, because x naught equals A and x1 equals B. So that's how you know, right? And then this gives me 1/2, and then when I put 1 ln of 1, supposedly it gives me 0. I don't know why. Is that correct, Jordan? 1 L of
Wait, let me
1.
look at what you got. So L, yeah, that makes sense because L of 1 is 0.
So then 0 times, yeah, correct. 0 times 0 just gives you 0. And then I did 2 times 0.2789, right? So this is probably incorrect, but the process is correct.
Yeah.
That gives me
No, actually, I didn't write it that way. I know why you wrote it that way.
You
Just
did
so
it
that's
one by
just
one,
easier to
right?
write.
Yeah.
But what I did was that I basically wrote it out. So it's like you have like 4 separate terms the way I wrote it out,
Correct, yeah.
and so it's like
You add them
you plug
each.
them in and everything. But yeah, obviously what you did is technically right. It's just that it looks weird.
Yeah, and then my error is correct. It should be small number, right?
Yeah. Well, let me actually look at your error. So
Because the error seems pretty similar. The error does get smaller, and then my Simpson.
yeah,
just
your
gets
error is
bigger.
correct. Yeah.
All right, perfect. So it's h squared over 12, right? And then 0.00521. Now we get to Simpson. This one is a little bit more complicated because this one you include everything, and then this one's just by 4. So this one I actually you go 1 to 6 over 4. So this is x0, x1, x2, x0, x1, x2, right?
Yeah.
As you can see right here, then this one's h over 3, f of 1 plus 4f, f of 4 plus f 6 of 4. And then we do the second one, the second little iteration, h over 3, f of 6 over 4. So you just, start where you left off, plus 4f 7 over 4 plus f of 2. This gives you your approximation. So when I plugged it in and added them up, I got this, which of course, again, I don't know how I got it so wrong, but yeah.
Oh, okay. I think I see it now. So I think oh wait, so for Simpson's rule, you're actually supposed to add like 2 things together.
Yeah, of course. This
Right.
is the 2
Like
things I
this.
added.
Okay, yeah, that part is good. I'm saying that it's that plus like, so in other words, like you're applying the Simpsons rule, like there's 4 intervals in
Twice.
total. So it's kind of like there's 2 things that you're adding together, if that makes sense.
Yeah,
So
just these 2. Yeah.
Where? The,
This one's one, and this is another one. This one is from here to here. This one is from here to here. I'm only
oh,
adding
okay,
two.
yeah, it's a little hard to tell because it's like you're writing the
Oh, yeah,
plus
yeah,
sign
yeah,
like
I know.
underneath it, so, yeah.
Yeah, Adam. My error though is negative h over 4 over 180. Sorry, negative h to the fourth over 180, b minus 8, f to the fourth, as you can see here. I don't have f to the fourth, but it's 2 over 1 cube. And that gives me a very small error. Again, if your error is really small for Simpson, normal. I have my f triple prime right here, and then f quadruple prime right here, so you can see it.
Yeah.
And I got 10 points because my process was correct, of course.
Yeah, of course.
Not because the
No,
process.
yeah, one last thing. So the error, by the way, all your errors for that question were correct. Because,
Thank
yeah.
you, bro.
All right, you said you
Thank
wanted
you
to do
for
question
making me
two?
feel better. Yeah, just so I could, practice.
Yeah.
Question 2 is, determine the number n of subintervals required to approximate interval from 0 to 1 of square root of x plus 1 plus e to the x plus cosine x. That's the question. It's exercise 2. So I actually have them labeled 2A, 2B, 2C. So this is 2C. This is 2A. Yeah, sorry. 2A, 2B, and then 2C here. So let's go over it here.
Yeah.
Alrighty, guys. So the first thing he wanted us to do was use a trapezoidal method, composite. So you have to calculate n to the 10 to the negative fourth, right? So as you know, h equals b minus a over n, right? So that just means in this case, from the integral of 0 to 1, h equals 1 to n, right? So you can use this information to actually find n. And you can find h, of course. Because if you have h, you can find n. You just get the inverse. So for this one, from what I remember, we only use error because h, you use h to get the error to 10 to negative 4, right? So you do h squared over 12, b minus a, which is just 1, to the second derivative, right? And then that's epsilon. And
Yo,
then,
we don't
right,
hear you, dude.
you hear me?
Yeah, now we can hear you, but like
Okay,
for
okay.
like 10 seconds, you were like,
Oh, okay,
I can
okay.
hear you.
And then so what I did here was I just I actually did 1 times the, so I got the interval right here, and then I made it as large as possible. And then I I have it right here 2.664. Then I multiplied 12 by both sides, and then I divided everything by 2.664 so I could get h squared by itself. Then I got this. So then what I did was I took the square root of h squared and then the square root of this number, gave me that h is less than or equal to 0.02122. And then h equals 1 over n. So I divided 0.0222122 by 1, and it gave me 48, approximately 48, right? So next thing here, we already have oh wait, sorry, this is Simpson's rule right here. So that means the next one, okay, perfect. So again, h equals 1 over n because b minus a over n. So this is for Simpson. So that means we do negative h to the fourth over 1/80th to the f of the f4 prime. So that just gives you this plus e to x plus cosine x, right? So now when you are solving for 10 to negative 4, you just want to isolate h. So I multiplied first by 180, both sides. Then I have then I solved this so I could get a single, a single number that I could divide by. Then I divided both sides by it. And then I when you divide 10 to negative 4 times 180 divided by 3.3414, you get this number right here, 0.005387. Then you take the fourth root of it, gives you that h is equal to 0.2709. Then when you get the inverse 1 divided by 0.2709, you get n equals 4, right? Gerardo, similar, right, to what you got?
Okay, so
So for the Simpson one, yeah, that I did get n equals 4. Now
Perfect.
for
Trapezoid?
CTR, I actually got 58. Do you think
The
that might
fuck?
have been error?
You might have been an error calculating the derivative, because the
Yeah, I don't
derivative
know.
is usually what causes the error, because the rest is straightforward.
Yeah.
Yeah.
And then CMR, I mean the midpoint rule.
CS midpoint rule. This one, right? 2C. Yeah.
Yeah, that should be it.
So for midpoint, it's easier. H squared over 6. This is what I got for the derivative. Remember, it's just, f double prime. It's gonna be the same thing as a trapezoid. So I multiply both sides by 6. I solve for the f double prime. Now that I have h squared and 10 to the negative 4 times 6, I divided it by my f double prime, which is 2.2664.
Mhm.
Then I took the square root of 10 to the negative 4 power times 6 divided by 2.2664. Which I first divided this so I could, get the correct answer. So then I took the second root, the square root of 0.000265, which is just this divided by this. That gave me h is equal to 0.0614. When I took the inverse, it gave me that n is equal to 62. And h is equal to 0.0163. Is that correct, Gerardo?
Okay, I actually ended up with 82. And the
Jesus
thing is
Christ.
that okay, I think I see the difference because so there it's like h squared is less than or equal to, okay, so the 10 to the negative 4, that's good. But the thing is that instead of what you have, which is that it's multiplied by 6, what I have is that 6 is on the bottom. So it's like divided by 6.
You divided by 6?
Yeah, yeah,
by
and
6.
then the opposite with the number on the bottom. I'm assuming that's like from the derivative. And so
Yeah.
instead of it being divided, it should be multiplied. I think that's why I got a different answer.
So the formula says for the error, h squared over 6 times b minus 8 times f double prime. So what I did was I first eliminated the 6.
Okay. Yeah, now I see it. No, because I was doing it where instead of using h, I actually went directly into I
You did
substituted
the
h
inverse.
for 1 over n. You know what I mean?
Right.
Yeah.
I found it easier to use h because to use 1 over n, it was gonna throw me off. But as long as we got something, and it's in the correct approximation, he doesn't mind. What's the next one? This one, right? No, this one.
Okay. And so so let me so you went over question 2, right? Like all of it?
Yeah, do you want to go over 3 now?
Yeah, I'll go over 3.
Let's
see.
There you go.
Gotcha. All right, I think I uploaded on Discord, so let me just pull it up. Oh wait, actually, let me share the screen.
Adrian says he wants to join in the study session, bro. He says he heard you're a great tutor.
Oh, I don't know. I don't know about that.
Bro, this man literally just, the email I just sent him, he just said okay in all caps. That's all he said, okay.
Okay.
I don't know why, but that sounds like something he would say, right?
He's a man of many words.
Bro, he literally just put okay in caps.
He should have just said I am following. That would have.
I am following.
I am following. That's all he should have said, man.
Yeah. Okay. So anyway, yeah, let's get on with this though, because this is recorded, so I don't want this to be like super long.
Okay.
Yeah. So the midpoint rule, so basically it's like this, and so using like the midpoint rules, like basically the rules for approximating, like you're using them, for this. Okay, and so you can figure this stuff out. So let me just pull up Discord. Okay. I think it's right here. All right, this should be it. Okay, so, all right, so this is for exercise 3, right? So for midpoint rule, so H basically pretty straightforward. And wait, okay, this is composite. No. Okay, so well, actually, it depends because for this one, I think at the beginning it said that the midpoint rule, not necessarily like the composite one, but the midpoint rule, and then the composite midpoint rule. Okay, so basically the first one is just midpoint rule, like not composite. So your H is just B minus A, so it's just 1 because it's it's 1. And so your f of x, you don't have to know what f of x is. It's just telling you like your function, right? And so basically, obviously like the midpoint here would be 0, so it would just be 2 times 1, which is your H, times f of 0, because that's the one in the middle here. And that's supposed to equal 24, right? And so it's just like algebra, right? You know, you divide both sides by 2. And so f of 0 equals 12, right? Then we get to the composite midpoint rule. So we have a number of subintervals. So basically, n is going to equal 4 here, and so you get with you get 0.5, right, or 1/2. So that means that you have this, so it's going to equal. So you end up essentially like with 2 integrals in a sense, right, from -1 to 0 and from 0 to 1, right? I just wanted to represent that, and so that's going to equal. Of course, the midpoint here would be -1/2, and then midpoint here would be +1/2, right? So it's just 2, part of the formula, times 0.5. This 0.5 is the fact that it's the h, okay? Times f of -0.5. Same thing here, right? It's just same thing. All this equals 10, right? And so once you simplify all this, you get this equation, which is f of -0.5 plus f of 0.5 equals 10, right? That's your equation. Then there's another equation that the question gives you, right? And that's how you're supposed to figure this out, right? So basically it says something where f of -0.5 equals f of 0.5 minus 1. Okay, so you have both these equations to figure out. And so basically once you do the algebra there, you eventually get f of 0.5 is 11/2 and f of -0.5 is 9/2, right? So is that good so far?
Yep.
Looks good, bro.
Okay. So then you get to composite Simpson rule. Okay. So again, number of subintervals is 4 here. So again, h is 0.5. So you kind of do the same thing. I like to write this out just to, symbolize it. So again, you use the formula again, right? So as you can see, right, you have the 4 of f of -0.5 there. See, again, you don't have to know what the function values are. It's just that you just have to write it out this way so you can, figure out what those values are. And then plus same thing here. All this is supposed to equal 12, right? And that's what the question told us, right? Like composite Simpson's rule gives us 12.
Yeah.
So, and so then you basically set it up, right? You distribute and all that stuff. And so that way you eventually get rid of all that stuff. Okay. How you do this, and by the way, this is a little complicated. So what I recommend is that, first of all, you get rid of the decimals, right? You just write this out as 1/6, right?
Yeah.
Basically you just kind of like multiply across by 6. That's what I did. So that way you just have no fractions, right? And so that's why this is 72, right? So basically, you do your math, right? You already figured out what f of -0.5 is. Like you already know like all the other stuff because what we've done so far. And so you basically can just figure it out pretty easily, right? And so you have another equation that the question gave you, right? When it came to f of -1 and f of +1, it already gave that to you. And we have this as well. And so we're able to figure out pretty easily, like with the algebra, f of -1 is 4, f of +1 is 4. Okay. That's basically it, right? Is that good?
Yeah, I got 2 and 2, but obviously I might have made a mistake.
Yeah. So you got full credit on that one?
Yeah, I got full credit. The last
Okay.
one's the one I didn't get full credit on because I forgot to invert. I had to invert the 1/x. I forgot to do that.
Yeah. Okay.
I'm only good when it's the ln, so hopefully I don't mess up in the exam, bro, for the least square.
Yeah. Okay. And this is the question someone gave me, I think. Someone said, "Oh, can you go over like question 4, like this one?"
Someone, oh, that was Ian. That was Ian. Yeah.
Yeah. Yeah. So here's the data, and you do least square approximation in this form. Okay. And it's actually not that complicated because that looks weird because it's written like a fraction that way, but you can just write it as a plus
yeah,
b over x,
over
or
X, yeah.
more accurately, it can be b times 1/x, right? And you can manipulate that a little bit. So let me just show
B
you.
times zero. Wait, what happened to the b times 1/x?
Yeah, because b over x is same thing as b times 1/x. Right?
What happens to the a?
No, the a is just like it's like the constant, right?
Oh, okay.
Okay, so let me just show you. Okay, so this is okay. This is just from the original equation that you just gave us, right? And you're
Yeah.
just kind of like rewriting it in a different way. So
Yeah.
so I wrote it like this, right? And so then you replace this 1/x with big X, right? So that way it's written in a way that we can manipulate, right?
Yeah.
So that's what we did. And so here it's like x, y. And then so it's like, okay, it's 1 over x in this case. And so it's just x, big y, right?
Yeah.
So what that means is that now when we convert the data, obviously the y values are not going to change, but the x value is going to change. All you have to do is just do the inverse of it, right? And so in this case, in fact, it actually makes sense because notice that all of them are like 1
Or
over something,
fractions,
right?
yeah. So now
Yeah,
it's
exactly.
a full
So
number.
so it wanted us to do this, by the way. So that shows you it's the right answer.
Yeah, same
So-
thing with the ln, right? Like if it's e to the this, e to the that,
Yeah.
you use the ln and that's it. Okay.
Exactly. So it kind of gives it away there, but again, it's probably not gonna be super obvious, but you know. So for that reason, when you convert the values again, so all you do is just you take each of these x values and you just flip it, right? So it's gonna be 1 over whatever that is. So 1 over 1, that's 1. 1 over 1/2, that's 2. 1 over 1/3, that's 3, etc.
Yeah.
Right. And so that's why we have 1, 2, 3 for these x values. The y values, they stay the same, obviously. Okay. Then you use this formula here, right? These two formulas, right? So the base formula is basically the sum of all the nodes you have, right? That's all it is, A. And then the sum of all the x values you have equals the sum of all the y values you have, okay? So just from this formula alone, all you have to do is just to get the next equations, if you will, all you have to do is just multiply across x
By x, yeah.
I, basically, right? So you multiply this by x. Now it's no longer the sum of the terms. Now it's the sum of the x values, right? Because you multiply here by x, right? Same thing
Yeah.
here. Now it's x squared, right? So basically the sum of all the x values, but each x value is squared, and then you add them all up, right? Same thing here, right? So it's going to be you multiply the x value by its y value, and then you add them all up, right? So all you have to do to get the other equations is that you just multiply across by x, and that's how you keep getting more and more. So the next one would be x squared a plus x cubed b equals x squared y, right?
Yeah.
So basically that's all there is to it. So in order to get those equations, you have to basically do that, right? So this 3a comes from the fact there's 3 nodes, right? 6 basically means that, okay, it means that we have 1 plus 2 plus 3, that's 6. Because we're adding the x values. 1 is just 2 minus 1 plus 0, that's just 1, right? And then of course this 6 is going to be equal to this a, like for the next equation, because it's the same thing, right? It's just xi, right? 14b, that's going to be x squared. So 1 squared plus 2 squared plus 3 squared, right? That equals 14. Okay. Then, wait, does it? Yeah, it does. Okay.
Yeah.
And then 0, same thing, right? So it's just, but this time it's x times y, right? So 1 times 2 plus 2 times -1 plus 2 times 0, right? And so you add that all up, that's 0, right? So then at this point, it's easy, right? Because all it is now it's a system of equations, right? We know how to do this. I mean, pretty easy. So once you do that, you got your A, you got your B. Okay, you're not done yet, because now you have to convert it back into how it originally was, right? So your A was just, yeah, well, basically like you convert it back into what it originally was, right? So originally it was, y equals A plus BX, okay? So you can replace that A with 7/3, replace this B with -1, right? And then you replace that big X with 1/x, right? So that way you kind of revert it back into how it originally was, right? And so you can write it like this, or you can write it like this because it looks nicer, right? So basically this is your final answer, right? So pretty much that's all it is. It's just that at the end you have to bring it back to how, so basically, so instead of it being A, obviously you want to write it into 7/3, right? Because you just solved that. Same thing with B. So
Yeah. So you think this one's easy, bro?
I mean, this question was easy, but yeah, I mean, I don't know about the exam though. Yeah.
I mean, let's hope it is, bro. Sure.
Yeah. Okay. So that's pretty much it. I think you said something about you wanted to go over 8.2.
Bro, because remember he said I have a feeling he's gonna put at least 2 questions on it. And if we're only getting 8 questions, bro, you know we're in trouble, man.
Yeah, I know what you mean. I mean, I don't know about the 8.2 thing. I didn't really go over it. Like, I didn't really study it, but
You didn't study it?
I mean, obviously I took
tried
notes on
to.
it, but I'm not
I
sure
tried
about like
to.
I'm not really sure how it works, but like,
How it works?
yeah. Oh wait, isn't it the same thing as just
Okay, so it's the same thing, but instead of discrete, it's continuous. So we have to integral. We have to take the integral. I was studying it, but obviously I stopped because I was studying the past exams. But I do have my notes on it. You want me to send them, or you have your notes as well?
No, I already took my notes on that.
The only thing that I am struggling with is the orthogonal.